Welcome to Spring LIB.
All right, so for the first part of this problem, we need to figure out the speeds, or rather the velocities of these balls after they have dropped and struck each other. So for this, we're going to use a combination of the conservation of energy and the conservation of momentum. The first thing is we need to know the velocity of the balls just before impact, and we can use conservation of energy to figure that out, where if we just look at the smaller ball, before it's dropped, it has a potential energy of mgh, where h is actually going to be L because this is going to be dropping down. So let's just write that as L. So mgl. And after it's dropped, the moment before impact, it's going to have a kinetic energy of 1/2 mv squared. And so if we solve for this v, the masses are going to cancel. We're going to end up with a square root of 2gl. That is how fast this little ball will be traveling. Likewise, the larger mass will also have this exact same speed because, as you noticed, the masses cancel out and are not in our final equation. From the conservation of momentum, we can figure out that the momentum of mass 1 plus the momentum of mass 2 just before impact is going to be equal to the momentum of mass 1 plus momentum of mass 2 just after impact. Well, they are going to have the exact same velocities before impact, so let's call that, so it's just going to be mv plus 2mv, where actually we need to subtract that because that's going to be moving in the opposite direction. And then over here, we're going to have mv1 plus 2mv2. So we don't know what v1 and v2 are yet. Well, all the m's are going to cancel out, and we can factor this. And so if let's just cancel those m's out, those are all going to go away. We're going to have v minus 2v, or negative v, is equal to v1 plus 2v2. Also, from our text, we learned that when we have completely elastic collisions in one dimension, we can write their velocities as v1 minus v2 will have to equal v2 minus v1. So the minus v, like so. And so if we rewrite this, v1 minus v2, it's going to be minus 2 times v. And if we substitute this in there, we should end up with 3v2 is equal to v. And if we remember, v is this right over here, square root of 2gl. So we actually have square root of 2gl over 3. And that is our speed of the second mass, the larger mass, as it bounces away. And then if we plug this back into this equation, we can find out what v1 is. So v1 will be negative 2v plus v over 3. And if we plug those in, we should end up with v1 being minus ourselves a little bit more space. Like so. So this is going to bounce back with that amount. Or you can put this underneath and you should get negative square root of 50 GL, because it's 25, square root of 25 times 2 all over 3. And this is going to be for the smaller mass. For part B, to find the height afterwards, we can use conservation of energy. So for the first one, the height that it's going to travel to is going to be equal to the conservation of energy, this height right here. We can use our conservation of energy equation, where this speed right there is the speed we just calculated right over here. So we're going to plug that in. So for this h, well, the m's are going to cancel. This b1, we're going to square this, so it's going to be negative GL over 9. So 1/2 negative GL over 9 all over G. So that G is just going to cancel out. So let's just get rid of it. And I forgot to put the 50 on there. Whoops. So that should be 50. So 50L over 9 times 1/2. That's so this 50 over 2, we're going to end up with 25L over 9. And then similarly for the other one, we're going to have 2 mgh is equal to that, which is square root of 2gl. So this is just mv2 squared, where we're going to have this right here, square root of 2gl. So the m's are going to cancel. And we're going to have gl over 9. That 1/2 is going to cancel with the 2. The g's are going to cancel. We'll just end up with L over 9. Let's get rid of that G to make that a little bit more clear. And there you go. So the height for the smaller mass will be L over, or sorry, the height for the larger mass is going to be L over 9. The height for the smaller mass is 25L over 9, so above that starting position.